Hello, everyone. I hope you all are doing well. So, um, can you guys first of all confirm to me, am I clearly audible or not before we will start and proceed with our session today? Uh, Try to wait for a few minutes so that everyone will join, and then maybe we will talk about today's agenda, where the major focus is to talk about the divide and conquer algorithms, right? I have already talked about the applications of divide and conquer in the playlist of DSA using Python, but the intro part is not there, right? So what I will do is I will try to add this intro part of divide and conquer in the same playlist of DSA using Python, so that if when you are studying this particular content, you will study in a sequence, right? And many people are saying that the lecture numbers are not in a sequence in DSA using Python playlist. See, in every playlist the sequence is there, but I can't mention the proper numbers. The only reason is, if I will mention, and in future if I want to add some new video, so it's very hectic for me to again change the complete numbers, right? But I will always make sure that whatever videos I'm uploading in the playlist, it will always be in a sequence so that you will not face any trouble. Okay, so we will start our session within a few minutes. All right. Meanwhile, if you have anything to ask from me, you can ask from me, right? Anything, whatever things I have been uploaded from the past week, you can ask the questions from there also, or anything with respect to your career, any guidance if you need, you can ask from me. If I have the knowledge for that, I will definitely try to share it with you, right? Any doubts, anything which you want to ask? And very first thing is, am I audible or not? That's the important thing, right? Is my voice is pretty much clear or not? So let me share my screen as well. Okay, meanwhile I'm sharing my screen, you can write your questions in the chat window. I will keep on looking into that as well. Just let me know whether the screen is also visible or not. Okay. Yes, is my screen is visible to everyone? Is my screen is visible to everyone? Right? So let's take few questions and then maybe we can start our session. Okay. So Sai Kumar is saying that which path is best for development, DSA or open source? See, data structure algorithms is something which you have to do, right? Open source contributions and open source is really good. You can do it simultaneously, but see, the purpose of DSA is to do the optimizations, and whatever thing you will do in terms of any of the domain, you should know that how you can optimize your code, right? For that, DSA knowledge is important. And second important thing is that whenever you are going for any of the interviews, you can't say that, okay, I have made a contribution in open source, but I don't know DSA part. No one will select you, right? If you are applying for a good product based companies, in that scenario you have to take both of these things simultaneously. It should not be or, it should be and. You should have a good knowledge of DSA, and you should contribute in open source as well, right? I hope it helps. S Kumar. Mohammed is saying, I'm unable to understand data structures. Any suggestions? See, it's very easy to understand. I'm not sure that what's the issue that you are facing in terms of understanding. That's what I am saying. If you guys can rigorously follow this playlist DSA using Python, it's a very matured playlist now. Okay, and you don't need to invest any single amount here in order to study this quality content. Believe me, if you will just go through all the videos which I have uploaded here, I am pretty sure that there should not be this statement that you will not able to understand. At least you should have a very good understanding, believe me. And today's session also, if you will observe, I have uploaded in this particular playlist itself. So here, if you will observe, this is the today's session, Mastering Divide and Conquer, Exploring Powerful Techniques. Now, what will happen after this session, after the completion of this live session, I will tell you that what is the path you have to follow, and what, in continue to that session which we are studying today, you have to do if you are listening this particular playlist for the first time, in order to get a in-depth understanding of this divide and conquer module. Okay. So I will give you a start. I will give you a push. I will introduce you this concept of divide and conquer in this today's live session. Why I came up with live and not the recorded one with respect to this module? Let me tell you, this particular module is pretty much important whenever you are going for any of the interviews. Okay. And uh, the live reason is that I can interact with you all. You can ask me the questions live. Okay. And I can answer you out. That's the only reason. Otherwise, I can also record the video and upload this inside this playlist. But I really don't want that. I really want to interact with you all. I really want to listen your concerns, whatever you want, be able to get an idea. And after that, I will show you the path, right? After this today's session, at the end of the session, please stay tuned until the very end. I will tell you that what particular thing after the session you have to follow, so that you will be able to get a proper understanding of this divide and conquer module. Believe me, you will be able to get it. It's very easy, it's very interesting. If you will listen the things which I am stating in today's session very carefully, you will enjoy it, believe me. Okay. uh, Anuj is saying Java mein nahi hai. It's completely fine. See, whenever I am talking about DSA, I hope you know the properties of algorithms. What is the property of an algorithm? It is independent of any programming language. So here, if you will see this playlist, there is a conceptual understanding which is more as comparable to the implementation. If you will be able to understand the logic behind any video, so for example, if you are studying quick sort, if you are studying finding of k at smallest element, anything. So if you will be able to get the logic what I am trying to state here, then you can implement in any programming language, right? Why you need to first of all see the code, whether it's in Python, it's in Java, it's a C++, anything. That's the beauty of DSA. You should come here to understand the conceptual part, right? Implementation, so we can see in Geeks for Geeks platform or any other platform is also there, right? The only focus of these videos which you are seeing in DSA using Python or Fang interview series is to have a logical understanding. Try to understand the concept, right? With respect to implementation per se, be it any programming language. I used to do DSA using Python, using Java. Sometimes I use C++, depending upon the demand. And when you're going for an interview, no one will ask you that, okay, do implementation in Java only, do implementation in C++ only, do implementation in Python only. No one will tell you like this. They will give you all the flexibility. What they really want to look for is that whether you will be able to have a optimized code or not, which will give a lesser time and the space complexity. And that is something you have to learn from these videos. My objective in these videos is not to cover up anything implementation per se. My objective is to teach you in such a way that you will be easily able to understand the concept behind every video, right? I have done my degree and post graduation in distance mode. I don't know basics of mathematics also. How can I prepare for DSA? See, when I'm talking about maths, you should have a 10th, 12th maths knowledge. It should not be like you should be pro in maths. Okay. So, whenever I'm talking about mathematics, if you will go to the starting of the videos where I'm talking about the bigger time complexities, recurrence relation, all these things, you will be easily able to understand the mathematical aspect also, right? Basic logarithmic properties should know, you should know basic AP-GP series, you should know in order to solve any recurrence relation. That's it, right? And if there is something like bit manipulation, number system, and all those stuffs will come into picture, I will separately create a video where first of all I will try to talk about the mathematical aspect, then I will try to talk about the implementation. In every video of DSA using Python or Fang DSA series, if you will see, I'm talking about the mathematical aspect first. I'm trying to explain that. I'm not pre-assuming that you know the mathematical aspect. So you will be able to get an understanding, that is for sure, right? There is not a I would say higher mathematical degree is required in order to understand a DSA. Basic maths is required. Basic is more than enough. That you already have learned in your 10th and 12th classes. That is for sure, right? It is difficult to maintain simultaneously doing DSA and open source. See, it's not difficult. If you will just keep on doing the practice, maybe on weekends, if you have a basic fundamental knowledge of DSA, what is array, what is linked list, what is stack, queue. After that, try to be in a routine where maybe on every weekend, Saturday and Sunday, where whenever you have the time, you should do some practice problems, maybe on lead code platform, maybe on geeks for geeks platform, maybe on any other platform where you think that you can apply your logic, whatever you know, right? See, it's kind of a logical building that you are doing. It's kind of a mental exercise also that you are doing. Why, be it any domain, interviewers are asking DSA in the first round. The simple answer is that they just want to see your logical building ability. They just want to see your IQ level. And DSA helps them to realize that how much IQ you have, how much logical building ability you have. That's it. So if you will just on every week also make a routine that okay, I will do almost 3 or 4 questions on a daily basis on every Saturday and Sunday, that is more than enough to sustain that DSA concepts. That is what I am saying. Remaining days you can do your open source contribution. No one is saying to you that don't do That's also important. So there are two aspects. One is the project building side, another one is the DSA side. You have to simultaneously maintain both of them, right? uh, I couldn't able to understand what is f of n and g of n while watching videos. Any suggestions? Should I learn any? So it's okay. Today I will talk about the intro part of divide and conquer, and you will be able to get what I'm saying as f of n and what I'm saying as g of n in that scenario. Okay, I will explain to you. Um, पुराने lectures की PDF नहीं है. I think everything is there inside this. If you will go inside this in my GitHub profile, in the repositories, if you will go YouTube session notes, you will be able to find the first repo. Inside that, if you will go now, there is a live session notes folder where you will be able to find out everything. Apart from this, if you are learning a stats playlist, so for the statistics session notes, there is a separate repository. Inside that, if you will go, you will be able to find out all the notes with respect to the stats part. I have mentioned also in the readme file that this repository contains the live session notes of stats playlist. So it should be there. If you find out that there is some video notes are not there, you can mention in the comment section of that video. I will look into that, and that is for sure in my local system, so I will upload that in the GitHub repo and share with you all. Okay, I hope it helps. How to improve the implementation part? By doing more and more questions. That's the only way. By doing a more and more practice, try to solve as many lead code problems as you can. Start with the easy level, try to do the implementation, try to find out the logic, implement it. Practice is the key for the implementation per se. That's the only thing that I have as a suggestion in order to improvise on your implementation part. Harsh reality of being a fresher and trying to get into data science. Do companies prefer freshers or being a fresher? Should we gain some experience as a SD before moving to data science? See, it's a problem here that as a data scientist, people are usually expecting some kind of a experience, right? And when we are as a fresher, if you are not from tier 1 colleges, you might face some trouble. So my suggestion is that it's difficult to get a full time role as a data scientist, but if you will try for the internship per se, you will be easily able to get that. So it's very easy for you to convert from intern to full time in any company as comparable to directly getting a job as a full time. So if you really want to go into this domain, you can directly jump as an intern, and then try to convert in that company itself and gain some experience, and then switch to other company. Second way is, it's also nice that if you are getting some good opportunity as an SDE, you will grab that. You will gain some experience, side by side explore data science stuff as well. And whenever opportunity will come, you can, because SD also you can consider as an experience. You will write in your resume, right? You will be having 1 year or 2 year kind of experience. But yes, you should have a solid knowledge and understanding that why you want to switch from, SD to data scientist. So that is something which you really have to understand here. I hope it helps. Python versus Java for freshers, which has more openings. See, both the domains have a equal amount of openings. You have to see that where is your caliber. If you want to become, software developer, Android developer, there are so many companies who are using Java, right? In that case, you can go for that kind of a language. If suppose your task or your dream is to become data scientist, or you want to go in a data specific job role, in that case I would suggest to go for a Python. And DSA is something where you can accordingly change your programming language and implementation with respect to what you want to become, right? That's the beauty of DSA, that you can implement in any programming language with respect to the interviews I am saying. But if you really want to become a good competitive programmer, hashtag rank one and also so on kind of a stuff, at that point of time obviously Java and C++ gives a faster execution time as comparable to Python. In that scenario you can consider using the Java or the C++. But apart from that, if you're really looking for just grabbing a good product based company, you can directly go and go with any programming language as per your ease, right? So let's start the today's session now. I think it's been a while that we are discussing lot many stuffs. I hope all the questions are being answered. Now let's try to focus next few hours or minutes, whatever time it will go, with respect to this session. Okay. So in today's session, we will try to talk about what is something called as divide and conquer. What is something called as divide and conquer? I will try to take one example here and will try to explain you the stuffs inside this. At the end of the session, I will try to talk about that after this session, what videos you have to go through in the playlist, so that you will be having a very good understanding after that with respect to this module. Okay. So please stay tuned with me until the end of the today's class. Okay. So let's get started. Whenever I'm saying divide and conquer, this particular algorithm is composed of 3 steps. The first step is, as the name suggests, that here we are trying to divide the bigger problem, I should say, into smaller sub-problems. The first task is, we are trying to divide the bigger problems into smaller sub-problems. I will give you the example also. Just first of all, listen what I'm saying here, and then we will try to see the examples. Meanwhile, in between of the session, if you face any of the trouble in understanding, you can write in the chat window. I'm looking into the chat side by side and will answer. Okay. So what we are doing, the first task is we are trying to divide a very big problem into smaller chunks. After that, we are trying to conquer, or I would say, we are trying to solve those sub problems via recursion. Now, I hope everyone, whosoever is watching these videos, already knew the concept of recursion. And at the very end, what we are doing is we are trying to combine the solutions of sub problems, right, to get a final result. So these are the 3 simple steps that we are doing whenever we are solving any problem via divide and conquer. Okay. So given any problem, the very first thing that you have to see is that what is the small problem corresponding to that. I will take very simple example. For example, if suppose I will give you a problem of sorting an array. Okay. If suppose I will provide you one array and I will tell you that, sort this array. For example, the array contains the data like 50, 20, 10, 27, 15, 35. So obviously, an array contains the index number 0, 1, 2, 3, 4, and 5. Now, if I will ask you to sort this array, what is the small problem in this case? Anyone, any idea? Who can tell me? Given this array, if I will ask you that the problem is to sort, what is the meaning of sort? That we want to arrange our items in such a way that it's in an increasing fashion or in a decreasing fashion. Let's consider it in an increasing fashion. So what I'm saying here is, what is the smallest problem in this case? What's the base case condition in this case? Whenever the problem is sorting, any answer can I able to get from anyone? Anyone? Any thoughts? What is the small problem here? Let's see who will be able to give me a correct answer. I'm looking forward to it. What is the small problem? Meaning that at what point of time you will be able to get an instant solution in a constant amount of time. You will not have to, do some bigger stuffs there. Anyone who can answer me? What is the small problem? If it is sorted, that also I have to see, right? Vamsi, whether it's sorted or not. Can I say that, the small problem is in this scenario when I will be having only single element, when I will be having only single element in an array? Can I say? If suppose I will say that I have an array which contains only single element like 50, right? In this case, what is the output? What is the sorted output? What is the sorted array? Who will answer me? Can I say in this case the answer is 50 itself? It's a small problem, right? If I will be having only single element, that element is sorted, no? Acha, at what point of time this is, I will get to know that this is, single element? If suppose I indicates the starting index of an array, which is equal to 0 in above case, j indicates the last index of an array, which is 5 in this case, right? Now, when you will say that I will be having single element in an array, when the value of I is also 0, when the value of j is also 0, means whenever the value of I is equal to j, can I say that it indicates that I will be left with only single element in an array? So this is something where I can say that it's a small problem with respect to the sorting part. It's a small problem. Is everyone able to understand what is the meaning of small problem and what is the meaning of bigger problem? Small problem means that instantly you will be able to generate the output within a constant amount of time. So within a constant time complexity. Is it clear, everyone? It's a small problem where I will be able to get a output in a constant time. What is the bigger problem? The bigger problem is when I will be having more than one element in an array. And what I'm saying is, whenever the problem is big, at that point of time, you have to apply these three things. First of all, you have to divide your problem into small problem. Then you have to conquer it. Then you have to combine the solution of every sub-problem. And this third step is something an optional step, which is for some applications, you will see that we are doing a combining part. And for some applications, we are not doing any combining part. Make sense? So what I have talked about, what is the abstract algorithm for this divide and conquer? I have told you that if suppose we are using divide and conquer strategy, given an array R, the starting index I, the ending index j, we will check if the problem is small. If the problem is small, containing array R, I and j, what is I? I indicates a starting index of the array and j indicates a ending index of an array. Ending index of an array. So if suppose the problem is small, in that case, what I will do? I will directly return the solution. This is what I told you, right? There is no need to apply divide and conquer in that case. I will directly return the solution containing air, I, and j. Right? But if that is not the case, if that is not the case, means we are dealing with a bigger problem. If the problem is big, in that case, what we will do? We will try to conquer it. What is the meaning of that? You will try to divide your task. First of all, the first task is to do the division, right? So maybe you are trying to find out the value of m, where you are trying to divide your array R, starting index I, ending index j. Then the second task is to do the conquering part. Conquering means trying to split your problem into two sub problems. So in this conquer, what you will do, you will use the recursion concept. You will use the recursion concept. What is recursion? Recursion meaning that if this is the method name, or if this is the function name that we have, if this is the function name that we have, what we are trying to do is we are calling the same function again, which is divide and conquer, but the parameters are air, I to m, divide and conquer, air, m plus 1 to j. So my complete array from I to j, I have split it down into two parts. One contains the elements from I to m, where m is the division value, and another one contains the values from m plus 1 to j. Suppose I am storing the result inside this b and c. What is the last step? Last step is to do the combine part, where I will try to combine the solution which I am getting. So what I will return is, I will return the combined part of b comma c. So that's the, I would say, abstract algorithm of any divide and conquer application, where you are starting your problem, you are just checking what is the small problem. If the problem is small, you are directly returning the solution. If it is big, you are first of all dividing it, then you are conquering it via recursion, and then you are combining the solution. This is the, I would say, abstract algorithm or the pseudocode of any application of divide and conquer. Now, to understand this, does it require any programming language? I believe whosoever is doing the DSA in Java or in C++ or in Python, everyone is able to understand this concept, right? I have mentioned, no code I have mentioned here. What I have mentioned is the logical understanding. And that is what you have to understand in every DSA portion. Don't focus on the programming language. You just have to understand that what is the literal meaning of whatever we are studying here. Then try to do the implementation on your own. Right? If you are good with any programming language, there is no need for you to, understand the step-by-step coding part, if you know the algorithm pretty well. Is it clear what we are doing here? Any doubt until so far? Now, how many of you have watched the video of recurrence relation, which a few days back only I have uploaded in my channel? How many of you have watched that video? This video I'm talking about, this particular video, 7 days ago, I have uploaded. Yeah. How many of you have watched this video? So, in order to have a understanding of how we can solve recurrence relation, you have to watch this video. So today in this particular session, I will not talk about that how you can solve the recurrence relation, because I am pre-assuming that you already have watched. If someone have still didn't watch, just bookmark it, and after the session, please go and check it out. In very much detail, with the examples, I have explained this video. It's a very big video, but it is something which you really have to understand in order to have a good knowledge of divide and conquer module or anything like recursion module, right? Okay, so if I will talk about what is the recurrence relation in this logic, who will tell me? Consider that dividing function is taking a constant task to divide my array into multiple subproblems. Obviously, when I'm directly returning the solution, it's also a constant task. Now, if suppose I'm dividing my array into two halves, So who will tell me what is the recurrence relation for this? If you will observe here, this is something that we are calling as a recursion, right? So what is the, yes, it should be nothing but is equals to T of n by 2. This is also T of n by 2. What we are doing here is we are trying to divide our complete n size array into two halves, right? So if suppose this method contains the time complexity as T of n, so the small solution will return me the answer in C constant time. Divide function will also return the answer in the constant time. This recursive code will give me T of n by 2 and T of n by 2. And let's assume that this combined process is also taking a constant time. As of now, it's my assumption, right? It's my assumption that combination and division is taking a constant time. So the recurrence relation of the above algorithm which we have mentioned will become, who will tell me what is the recurrence relation of the above term, above method that we have mentioned? Yes. So as Vikas Kumar and Kode have mentioned that it is, no, it's wrong. So it's this one is correct. This is also wrong. Oh my God. Who will tell me the correct answer? So there is something wrong in both the answers. So it should be something which is equals to T of n, which is equals to, see, we have 2T n by 2, right? One is this, another one is this. So I am adding these two. So it will become 2Tn by 2 plus remaining things are constant. So if I will just add the constant terms also, it will become C plus C plus C. It will be nothing but 3C. So what I'm writing is a normal constant because constant terms we are not picking up. So this is the correct recurrence relation that you will be able to get when you will use the above logic to solve the divide and conquer approach. It will be 2Tn by 2 plus C. Now, how this recurrence relation we can solve via substitution method or via Master's theorem, that you already can see from that video which I just now referred, right? If someone has not watched that, I would highly recommend that after the session, go and watch that video. Very, very important to understand that how we can solve any recurrence relation, right? But today's focus is not about that. Let's focus on only the divide and conquer module only, that what's the purpose of using that particular part. Any real-time application which you know with respect to this domain? How many of you are aware about something called as big data domain? Big data. So let's talk about what is the real-time application of this algorithm. How many of you are aware about this domain called as big data? Anyone, any idea, anyone have heard of? I think everyone must have heard of this term. Maybe they don't know the very in-depth knowledge about that, but at least they should be aware about what is this big data. So this big data also follows the principle of divide and conquer. Why this domain came into picture at the very first place is because data is too huge, right? This big data tech stack is used only when you are dealing with the data which is too huge, right? No one will use this big data tech stack in a small kind of a data. And what I'm saying is this tech stack also follows the principle of divide and conquer. How is that so? For example, if I will give you one very big document, okay, and maybe the document size is 100 TB. Let's consider 100 TB is the document size. And the problem statement is that you have to count in the complete document that how many number of occurrences, or you can say the frequency. What is the frequency of the word named Priya? How many times this Priya string is, coming up? You just have to count that. Now, in my local machine, in my single machine, obviously I don't have supercomputers. So my machine will not able to handle that much huge data. And that's the problem which researchers initially faced when they're trying to solve these kind of problems in a very big data. So what they come up with? They come up with something called as divide and conquer strategy. What they said is, why not to divide this document into maybe 4 parts and give 25 TB, next 25 TB, next 25 TB, next 25 TB. In this way, we will be having in total 100 TB of data. But now I have given individual machines, which we called in today's world as clusters, right? Why not to give 25 TB of data in every machine? Now the task will remain same. What is the so this is something which is the division part, divide. So what we have done is we have divided our main problem, which contains 100 TB of data, into 4 smaller sub problems. Sub problem number 1, sub problem number 2, 3, and 4, which we called in today's world as clusters. So every machine is handling 25 TB of data. And now every machine is doing the same task, that is to find out the frequency of the word Priya. So now it will try to conquer, meaning try to find out the solution of how many times Priya string is occurring. Maybe in the first 25 TB, Priya string is occurring 10 number of times. In the second machine, in the next 25 TB, it occurred 5 number of times. In the next case, it occurred 3 number of times. In the next case, maybe it occurred again 5 number of times. Now, what will happen? The last step is to combine, because I don't want individual solutions. What I want is, I want in the complete 100 TB data, what is the total frequency of the string named Priya. So what will happen is, the last step is to combine. So what will happen? All the solutions will get combined together. So there will be a third phase, which is a combine phase. And in the combination part, what they will do is they will just add the answers of all the machines. 10 plus, 5 plus, 3 plus 5. And they will come up with answer as 23. Simple. So the task which was not handled by single machine, now the same machine, I am having 4 machines similar to that, and individual machine is taking a small data, and every machine simultaneously doing the task and will be able to give me the answer. This is also known as distributed computing, right? This is the fundamental of distributed computing, or parallel processing, you can say. In simple words, I would say this is the fundamental of doing a parallel processing. Parallelly, I am processing the task. So what will happen is, I will be able to get the output very easily, very fastly, and it will not require a huge amount of GPUs as well in order to process my data. So easy, right? Same approach, algorithmically divide and conquer. First task, dividing. Second task, conquering. And third task is combining. Complete tech stack is built on this only, of big data. So there we will be having Hadoop to store the data, MapReduce or Spark is to process the data. But the fundamental part is this only, which I'm talking about today. Is this clear to everyone? Now I hope everyone will be able to understand what is the meaning of divide and conquer and how basically it actually works. Is this clear to everyone? Any doubt until so far? I am just taking 2 minutes of pause here. If you have any doubt, please ask. Otherwise, today we will discuss one application called as merge sort, okay, which is very widely asked in a lot of interviews. We will discuss this with the implementation. I will do the live implementation, and then maybe you will be able to get a very great picture of this divide and conquer module. Shall we start? Okay, so let's start then, if no one is having any doubt. Suppose I will be having some data. Okay, so data is 50, then I will be having 30, 25, 21, Then I'm just randomly writing any numbers here, 16, 10, like this. So here, obviously, the index number will be 0, 1, 2, 3, 4, and 5. So in total, in a way, we will be having six number of elements. The value of I, which is the starting index, is 0. The value of j, which is the ending index, is 5. Right? Now, this merge sort is a application of, again, divide and conquer module. A very famous application, I would say. Right? Now, what will happen? Again, I will be having a bigger problem because it's a array which contains more than one element. Few minutes back only we have discussed that whenever we are talking about sorting, so if my data contains only single element, then only I can say that it's a small problem, right? If it's a more than one element, it's a big problem. So what I will do is I will be having a complete array R. Let's consider this array as R. And what I will do is the starting index of this array is 0, ending index is 5. What is the first task? Because the problem is big, we have to divide our problem into two parts. So how basically we will divide? We will try to find out what is the middle value. And then we will divide our problem into two parts. So what will happen? Middle is equals to 0 plus 5 divided by 2. So it will be equals to 2. So what will happen? On the left side, I will take the element from 0 to 2. And on the right side, I will take element from 3 to 5. So I have divided my array into two sub-halves, into two sub-problems, right? So I have taken the left sub-array from starting, if it is I, it is j. So my left sub-array will contain the elements from I to mid. And my right sub-array will contain the elements from mid plus 1 to j. Make sense? Make sense? Now, still, if I will ask you, how many number of elements do I have in this array? How many number of elements do I have in this left sub-array? Who will tell me the answer? How will we calculate the total number of elements that we have in an array? What is the higher index? It is 2. Minus, what is the lower index? It is 0 plus 1. It means still we will be having 3 elements in the array. Again, the problem is big. We have to split our problem again into two parts by finding out the middle value. So again, the value will become 0 plus 2 by 2, which will be 1. It means left sub-array will contain the element from 0 to 1, and the right sub-array will contain the element from 2 to 2. Again, it contains two elements. So what I will do, I will again split it 0, 0, and the right side will contain 1, 1. Similarly, in this case, on the right side, it will be 8 by 2, which is 4. So R of 3, 4. And on the right side, we will be having R of 5, 5. On the left side, again, it will be R of 3, 3, R of 4, 4. It means that we need to keep on dividing our array into two sub-halves until we reach to a small problem, right? So this is something that we called as complete recursive tree. This is something that we called as complete recursive tree. Now, in this case, if you will see how the execution will happen internally in this recursive tree. First of all, the function call will go to the C1. Now, because we are using recursion and recursive function calls will store inside which data structure? Who will tell me? Recursive function calls, where it will get stored? In what data structure we are storing recursive function calls? Who will tell me? Anyone? What is the data structure to store the recursive function calls? It will be something called as very good. So the correct answer, as said by Bharat, is stack, right? So stack stores the function calls. So what will happen is, initially it will start from the, so in the recursive, in the tree data structure itself, this is called as root node, right? The very first node is root node. And the last node, after which there is no child, is called as leaf nodes. I hope everyone knows these basic things, right? So what will happen is, we will start from C1. Now C1 will, call will get stored inside this stack. Then what will happen? C1 will go towards C2, right? C2 will also not return the solution because it's a big problem. Then C2 will call what? C3. C3 also don't return the answer because it's a big problem. C3 will call something called as C4. So this is C4. Now this is a small problem, right? This is a small problem. Why? Because here we will be having only single element, 0 comma 0. When the value of I is equal to j, few minutes back only we have discussed. At that point of time, it indicates that we will be dealing with a single element. And if array contains single element, what is the output? What is the sorted data? Can I say it will be nothing but is equals to 50 itself? Because at 0 comma 0, 50 is the answer. So directly, because it's a small problem, it will return to me the answer as 50. Will everyone agrees with me? So C4 will return the answer to me as 50. And again, the function call will go back to C3. Now C3 will say that I will be having a left side answer that's completely fine. What is the right side answer? Means it will call the C5. So now C3 will call a new function which is C5. Now C5 is again a small problem. Why? Because again the value of I and j are equal. But it contains the element at index 1. What is that element? The element name is 30. So what will happen is, it will again directly return the answer as 30 here. Right? Please listen these things very carefully. You will not find this kind of explanation anywhere on the YouTube. Believe me. And I'm doing it live because I really want to take your questions as well. So in between, if you really want to get stuck anywhere, you can ping me at that point of time itself, right? So here, if you will see, at C5, the output will be returned. So again, the function call will go back to C3. Make sense? Now what will happen? Again at C3, that's where the combination part will come into picture. So what happened? When I moved from top to down, divide part came into picture. We are conquering it until we reach to a ending solution. So we are getting an answer, it means we are conquering it. Now when you are moving from bottom to top, a combined part will come into picture. And that is something which we called as merge procedure. That is something which we called as merge procedure in merge sort. So merge procedure is responsible to do the combined part in merge sort. So what this particular function does, this function is responsible to take a left sorted subarray and the right sorted subarray as an input and give us a sorted array. Give us a sorted array. So what will happen is, when you are moving from bottom to top, C3 will return the answer as 30, 50, a sorted array. Is it clear? So now C3 will also return the solution. Now the function call will go back to C2. Now C2 will say that, okay, I will be having a solution of left side, but I really want a solution of the right side also, C6. C6 contains again a small problem, but at the second index. So element will be 25. So now the 25 will be returned. Again, the function call will go back to C2 because C6 now returned the answer, right? So C6 will be called, C6 returned the answer, C2 will be called again. Now, again, can anyone tell me what is the output of C2? Again, when I am moving from bottom to top, merge procedure will be called, and merge procedure will be responsible to give me the sorted output. So what will be the answer here? Anyone who can tell me? It will be equals to, as correctly said by Vikas Kumar, it should be 25 followed by 30 followed by 50. So merge procedure will give me the sorted data. How will it give to you sorted data? That we will talk about later. But as of now, you have to understand that there is something called as merge procedure which is working, whose basic responsibility is to take the left sorted subarray, right sorted subarray, and to return a final sorted array. Now what will happen? C2 returned the answer. Now the function call will go back to C1. C1 will say that, okay, I will be having an answer of C2, but I also know the answer of right side. So what will happen? Now C7 will be called. So now C1 will call something called as C7. C7 will say that I don't have an answer. It will call C8. So C8 will be called. C8 is also a big problem. C8 will call C9. So C9 will be called. Right? Now at C9, again it's a small problem, right? I and j are equal. So it will return the answer as third index, which is 21. Which is 21. So now C9 will return the answer. Function call will go back to C8. C8 will say that I should also know the answer of C10, right side. So now C8 will call C10. C10 is again a small problem containing the index number 4. So it will return the answer as 16, right? Because it's a small problem. Now, when again we are going back to C8, who will tell me what will be the output my merge procedure will return? What will be the output my merge procedure will return at C8? It will be what? Very good. As said by Ayesha, it will be 16, 21. Right? Now, C8 will also return the answer. Function call will go back to C7. C7 will say that I should know the answer of C11 as well. Now, it's a small problem. At index number 5, it will return the answer as 10. Right? Now, again, when C11 will return the answer, so C11 will also return the answer. Function call will go back to C7. Now, what does C7 will return to me? Who will answer me? What is the output given by C7? C8 contains 16, 21. C11 contains 10. So, what will be the output at C7? It will be very good. So, as said by Code, it will be 10, 16, 21. Make sense? After that, now we will again go back to C1. Right? Now C1 will be happy. Why he is happy? Because he is having the answer of left side as well as the right side. So what will be the final output returned by C1? Who will tell me? What will be the final output returned by C1? It will be equals to, who will tell me the answer? It will be equals to, very good. Great. It should be equals to 10, 16, 21, 25, 30, 50. And this is what we really want, right? This is what we really are looking for. Sorted array. And we will be able to get that via the merge sort. This is how simply merge sort will work. Does this require knowledge of Python programming language? Does this require knowledge of Java? Does this require knowledge of C++? No. I believe if there is someone from any of the programming language, everyone can understand this, right? Right? I hope everyone will be able to get the logic. So what we have done here, if I write the pseudo code here, what we have done, if suppose we will be having a function called as merge sort containing the array r, starting index I, ending index j, we have checked if the value of I is less than j. What is the meaning of that? That we are dealing with a bigger problem, right? At that point of time only we will be having the value of I less than j. What we have done here, first thing is we have done the division. How we have done the division? By calculating the middle value, which is equals to I plus j minus I by 2. Second step, we are doing a conquering. How we have done conquering? By calling the same function again. So if this is the function name, that we have. So we are calling the same function again, which is merge sort, right? But on the left subtree, we will be having elements from I to mid. I hope you all remember. This is on the left subtree part. And on the right subtree, we will be having the elements from mid plus 1 to j. Mid plus 1 to j. This is on the right subtree part. Right? If you will observe, this is what I have mentioned, right? I to mid on the left part, mid plus 1 to j on the right part. And that is what we have done. So conquering is also done. Conquering means we are calling our same function again and again, recursively. The last part is combining. How we are combining our solutions? By using a function called as merge procedure, which will take the value r, I, mid and j. Right? This is the combining part. This is an application of divide and conquer. Is it difficult? Anything which you will not able to understand? Now, how this merge procedure is working? If suppose I will be having a left subarray, so what we are passing in the bottom part is the left and the right sorted subarrays. So if suppose I will be having a left subarray like 20, 20, 30, right? And 40 suppose. And on the right subarray I am passing 11, 21, 31 and 41. Suppose the index number is 0, 1, 2, 3, 4, 5, 6 and 7. Suppose this is a part of a left subarray. And suppose this is a complete part of a right subarray. Now, if I'm asking from you how this merge procedure will work, it will take a pointer. One pointer is at the value I, one pointer is at the right subarray j. And what it will do is, it will copy this array, copy these values in the left and the right subarray and change the original array now. Right? 0, 1, 2, 3, 4, 5, 6, 7. So what will happen is, it will try to compare the elements on the left and the right subarray. Means 10 and 11 will get compared. Whichever value is smaller, we will just copy it inside the array r. Then we will increment this pointer I, because we have just now taken the value from left subarray. Now again 20 and 11 will get compared. Which value is smaller? That value you will push into the array. You will increment that corresponding pointer as well. Next comparison will happen between 20 and 21. Which value is smaller? 20 is smaller. You will push and then increment the pointer. Again, the comparison will happen between 30 and 21. Which is smaller? 21 is smaller. So you will increment the pointer. Again, the comparison will happen between 30 and 31. Which is smaller? 30 is smaller. Again, you will increment the pointer. Now, again, what will happen? There is a comparison between 40 and 31. Which is smaller? 31 is smaller. You will increment the pointer. Again, there is a comparison between 40 and 41. Which is smaller? 40 is smaller. Now, when you increment the pointer of I, you will be out of loop, right? You will be out of loop because your left subarray, which is M, contains only 4 elements and you have traversed all the 4 elements. But still, your right subarray contains single element, which is 41. So, what will happen is whatever element is left, you will just copy it at the very end. This is how completely you will be able to get a complete sorted array with the help of a merge procedure. So what will happen is it will try to compare step by step every element present inside left and the right subarray. Whichever element is smallest, it will try to copy that element inside the original array that we have. So if someone will ask you in the worst case how many number of comparisons your merge procedure will make, can you count it? How many number of comparisons we have? 1, 2, 3, 4, 5, 6 and 7. It means in the worst case scenario, the merge procedure number of comparisons will be equals to m plus n minus 1, where m is the size of the left subarray, n is the size of the right subarray, minus 1. That's why if you will observe here, our value of m in our case is 4, n is also 4, minus 1, which is equals to 7. That's why we will be having 7 number of comparisons here. This is the worst case. Why it is having 7? Because every time, one time I am picking up from left, another time I am picking from the right. Then from the left, then from the right. Then from the left, then from the right. Then from the left, then I am left with a single element. So I just copied it down. But if someone will ask you what's the best case scenario, what is the best case number of comparisons? Means what is the minimum number of comparisons you will be having in the merge procedure? Or at what scenario you will be having a minimum number of comparisons? The scenario will be like, if suppose you will be having elements like, 10, 20, 30, 40 in one case, and in the right subarray, maybe you will be having elements like 5 and 6. So what will happen is, I is here, j is here, you will compare 10, 5. So it will be 0, 1, 2, 3, 4 and 5. Again, I will be having an array, which will be 0, 1, 2, 3, 4 and 5. So what will happen? 10 and 5 will get compared. 5 is smaller. I will copy it down. I will just increment the value of j. So 10 and 6 is compared. 6 is minimum. I will just copy it down. Now after that, if you will observe, when I increment the j, there is nothing. I have completed my traversal on the right side, right subarray. So what I will do, I know that the left subarray is already sorted. So what I will do is I just directly copy down all the elements. So copying will happen here. It means I just have only 2 comparisons. So in the best case, your minimum number of comparisons will be minimum of m, n, considering m as 4 here, n as 2 here. That's why we will be having minimum of 4, 2 as 2. Is this clear to everyone? How this merge procedure is working? So in worst case scenario, I will be having m plus n minus 1 number of comparisons. So when I'm talking about the time complexity aspect of this merge procedure, it depends on the number of comparisons that we are making in our merge procedure, plus how many number of movements you are doing. Now, what is the meaning of movements? How many elements you are, moving from left subarray and right subarray to the original array? We are moving all the elements, right? And in worst case, how many number of comparisons do we have? It will be m plus n minus 1. So can I say that the time complexity is big O of m plus n? Or if capital N is the size of my complete array, so it will be big O of capital N. So it means that if I will go back to the procedure, this dividing part contains a constant type because we are just applying a formula. Here we are dividing our array into 2 parts recursively. So it will be capital N by 2 and capital N by 2. And this combined part will again contains big O of n. Just now we have discussed. If suppose the time complexity is T of capital N, so what is the recurrence relation we will be able to get here? The recurrence relation of any merge sort will be something which is equals to T of n, which is equals to 2Tn by 2 plus big O of n. Is everyone agrees with me? Because we are dividing our array. So this is nothing but is equals to the number of subproblems. This is nothing but is the size of subproblem. And this capital N is the combined time complexity, which is the merge procedure that just now we have discussed. So if you will solve this via substitution method or via Master's theorem, you will be able to get the time complexity as big O of n log n. Big O of n log n. If there is someone who don't know how we can solve this recurrence relation, please go and watch that video which I just now referred. Solving the recurrence relation methods. So that's why merge sort contains n log n as the time complexity. Now, if you have any sort of doubt, please ask. At the very end of the session, I will just now show you the implementation also with whatsoever things we have discussed, and then maybe we can wrap up the session. Any doubt anyone is having before we will move and proceed towards the implementation part? One more thing is we are using extra space here, right? Left subarray and the right subarray. That's why it is also called as outplace sorting algorithm, because the space complexity in this case will be equals to big O of n, because we are using a extra space here to execute our code to sort the array. That's why it is called as outplace sorting algorithm. What is the meaning of outplace? That we are using an extra space to sort our array. Right? Any doubt anyone is having before we will move ahead towards the implementation of this? Now I will do the implementation in Python. If you really want at your home, you can try the same implementation in Java, in C++, or any other programming language as well. JavaScript, any language which you are comfortable with. If you know this pseudocode, this logic, what I have explained in the last 1 hour, you can easily implement it. That is for sure. Right? Shall we go towards the implementation now? Yes or no? Yes. So what we can do here is, the first thing is I will try to write the driver code here, okay? Where we can define the array manually. So we will be having a list of unsorted arrays, for example, 50, 27, 20, 10, 12, 17, 8, something like that, right? Now the starting index is 0. The ending index will be nothing but is equals to what is the length of the array that we have minus 1, right? Now here what we can do, we can call our function which is merge sort, and inside that we can pass our array r, the value of I and the value of j. And finally we can print our result, right? Now let's try to do the function definition of merge sort, which we have called here. So this is where we have done the function calling, right? Now we can define our function which is merge sort, which contains array r, the value I and the value j. What we can mention is, if the value of I is less than the value of j, what does that indicate? That simple indication is that we are dealing with a big problem. And we know that this divide and conquer application of the approach is suitable only for the bigger problems, right? Now what we can do is, first task is to divide our problem. So mid is equals to I plus j minus I divided by 2. After that, second task is to conquer it. So we will call our same function again, merge sort, but the parameters will be ar I mid, and again merge sort with ar mid plus 1 and j. And finally, we will call our combined part, which is merge procedure. And here we can call ar, what is the value of I, what is the value of mid, what is the value of j. And finally, we can return our array here. Any doubt in this part? Until this part is everything is fine to everyone. Before I will try to now show you the method implementation of this merge procedure, because here again we have done the function calling, right? Function calling of combined part. Before that, this is the first step, which is the divide, right? This is the second step, which is the conquer. So we have divide the bigger problem into sub problems. Now we have conquered the sub problems via recursion. So below is a recursive function call. So this is a recursive function call for a left subarray, and this is a recursive function call for a right subarray. Right subarray. And then finally is the third step, where we have done the combine part. Combine the solution of left and right subarray. Left and right subarray. Any doubt until so far anyone is having, please ask before we will proceed towards implementation of this merge procedure. Anyone, any doubt? So if there is no doubt, let's target towards the function definition of merge procedure. What we can say, def merge procedure, which is equals to ar I mid and j. The first task is to calculate the value of n1, which indicates the number of elements present inside the left subarray. Now, who will tell me if suppose left subarray lower index is I, higher index is mid, so how many number of elements do we have in left subarray? What will be the answer? Just few minutes back only I have talked about the formula. How we can calculate the number of elements given a lower index and the higher index of a value? Anyone can tell me here? So what I am asking is, tell me the number of elements, formula to calculate the number of elements in left subarray. Who will tell me? And also tell me how many number of elements in the right subarray. How will we calculate? Very good. It will be, as already told by Vikas, it will be equals to, in the left subarray, it will be equals to mid minus I plus 1. So the formula is, what is the higher index minus what is the lower index plus 1. So in the n1 case, it will be mid minus I plus 1. Who will give me the formula for calculating the n2 value? Given the lower index is mid plus 1 and the higher index is j. Lower index is mid plus 1, higher index is j. So what is the formula? Again, it will be j minus mid plus 1 plus 1. So if you will solve this equation, very good. You will be able to get the answer as j minus mid as told by Vikas. Right? I hope it is clear to everyone now. Now what we supposed to do? We supposed to copy the elements inside the left subarray and the right subarray. So first of all, we need to initialize left and right subarrays. And right subarrays of size n1 and n2. So what I will do, I will take initially L subarray, which will be equals to, I will initialize initially via 0. So every particular L subarray contains 0, 0, 0, 0 only, and right subarray also contains the element 0 of size n2. Fine. Initialization is done. Now what I will do is I'll try to copy the elements from original array to left and right subarray so that we can start doing the comparison, right? So what we will do, first of all, we will try to copy the elements from original array to left subarray. So what I will do for m in range n1, which is the size of my left subarray, what I will do is I'll try to copy the elements inside this L subarray of m, which is equals to r of, from where I supposed to start? From the value of I, which is the starting index, plus m. So the copying of the elements in the left subarray happened. Now the copying of elements in the right subarray we have to do. N2, what will happen? R subarray in the n, which is equals to r. What is the lower index in the right subarray? It is mid plus 1, right? Plus the value of n. The lower index in the left subarray is I, lower index in the right subarray is mid plus 1. So we are starting from I, going until the value of m. How much is the value of m? It will go from 0 to n1 minus 1. Similarly, we are starting from mid plus 1 in the right subarray, will go until the value of n. What is n? It is n2 minus 1. Is it clear? So what we have done is we have just now copied the elements from the original array to the left and the right subarray. Now, the final task is to do the comparison, right? So for that, we will take up pointers now. So suppose the value of p, which will point to the left subarray, is 0. The value of q, which will point to the right subarray, is also 0. And the value of k, which will point to the original array, is equal to the lower bound of my array, which is equals to I. Now, the actual comparison will start. Actual comparison between the elements in L subarray and R subarray will happen. So what will happen? We are saying while loop until my value of p pointer is less than n1, which is responsible to taking care of the left subarray traversal, and q less than the value of n2, what you will do? Just check. If the L subarray of P is either less than equal to R subarray of Q, what you supposed to do? Who will tell me? If the left subarray element is smaller, what I really want to do? I really want to insert that L subarray value of P inside this array. And then I will increment the value of P by 1. Right? I will increment the pointer by 1 of the left subarray. If that is not the case, then what I really want? It means vice versa. I really want to copy the element from R subarray of Q and increment the Q pointer. In any of the cases, K pointer will always get incremented. Why? Because we are copying at each and every time the element inside the array, right? So I hope this part is clear to everyone. Any doubt in this part? What we have done here? So what I have said here is, this is something which I have noted as P. This is something which I denoted as Q. And what I am saying is, this is Q. And this is something which is K, which is initially 0. So whichever element is smaller, we are copying the element inside this arrow of K. Then we are incrementing that particular pointer. And at any point of time, doesn't matter whether P is incremented or Q is incremented, K value will always get incremented, right? Because at any point of time, we are inserting the values inside this array. Now, going back again to the implementation part, the last thing which is pending is, if suppose we come to the situation like this, where one particular array is completely done, but remaining elements are pending on the other side, what we supposed to do at that point of time? We're supposed to copy all the elements, right? So if suppose after iterating this complete while loop, still the elements are pending, maybe in the left subarray, first of all, consider that the values are pending, that p is less than n1, still values are there. What I will do, I'll directly copy all the elements that I have in the L subarray, right, of P, and now I will increment the value P by 1 and the value K by 1. Similarly, if suppose there are still elements that are present inside the R subarray, again I'll do the same task. I'll copy all the elements in the right subarray of Q and then I'll increment the pointer of Q by 1 and I'll increment the pointer of K will also by 1. That's it. I believe everything we have done right. So if I'll just run this, I think I'm getting a correct answer. It's a sorted array, right? So what we have done here, so copying is done, right? We have copied the remaining elements from left subarray if it is pending, and then we have copied the remaining elements from right subarray. Done. So simple, isn't it? So if we understand the concept pretty well, implementation, I don't think it's very difficult, even though people usually get afraid with this kind of a code. But those who are afraid, it means that they don't know the internals of this particular algorithm. That's the real meaning of that. Right? Any doubt in this particular part, what we have covered up here? So if someone will ask you what is the time complexity, first of all, you have to generate the recurrence relation. And after that, when you solve that recurrence relation, so this is the implementation of merge sort. We have seen the recurrence relation as T of n, which is equals to 2t n by 2 plus n. If we solve this via Master's theorem, you can try at your home, you will be able to get the answer as big O of n log n. Yeah, that's all about today's session, which I really want to cover up. And I think you find it insightful. Now, after this particular session, what I really want from you all to cover up is the upcoming application, that is the quick sort, implementation of that, selection procedure, implementation of that. So these are the applications of this divide and conquer only. So I'm not repeating the things which I already have covered up in my playlist. You can go and refer now below this video of today's video. There are applications which I already have covered up that will really help you to understand now in very detailed further concepts of this divide and conquer. I have given you the intro part today. I have talked about the conceptual understanding of what is divide and conquer, how it works, and have discussed a in detail application of merge sort, that how basically it will work with its implementation, right? I hope that you find it insightful. What things you have learned from this session, what are the aspects you have learned, do mention in the comment section in a very brief, so that I will also get to know that okay, whether you have gained some insight or not. And I will make sure that whatever notes I have made while teaching you live, or whatever implementation I have done, I will upload in my GitHub repo and will attach the link also in the comment section. I believe if there is no queries, we can end the sessions just now itself. And if there are some questions you have, you can ask. I am waiting for you all. Next 1-2 minutes I am here, and then I'll end this today's live. And you can give me your feedback also, whether you will be able to understand the things which I'm teaching here or not. I'm looking forward to your feedback in the comment section or in the chat also, right? Any questions you have with respect to what we have learned today? I hope everything is sorted, clear. Now, those who are saying that how that recurrence relation is generated, I hope everyone is able to understand the concept now. And what you have to do now after this particular session is also clear. Right? All clear? Perfect. So thank you so much, everyone. I'll see you all very soon. Yeah, we will do these sessions. I think every week we usually do. Next week also, means upcoming week also, I am planning one more live session with you all. So stay tuned. If there is someone who is not connected with me via LinkedIn, also please do send me a connection request. I will approve it. And in the community post also on my YouTube, also I will make sure that I will keep on posting that. But whenever the session is happening, make sure to subscribe the channel. Make sure to hit a like button. Make sure to share these videos as much as you can for those particular students who really need to understand these kind of concepts and they are really struggling. I really want this particular videos to reach to as many people as much we can, right? Thank you so much, and I'll see you all very soon in the upcoming live. Till then, keep learning, keep hustling, and bye bye, and take care. Okay, good night.